Okay, great. We're actually recording right now. I already did this recording a moment ago, but then I discovered at the end it wasn't actually recording. So this is my data analysis for the profiling data GUI so far. I'm gonna walk over like what is what. This These are like frame versus time graphs showing you time spent doing this operation. Uh, there's the frame, and then there's different steps of the clustering process. And I have the CPU and the GPU graphs for each one, but the CPU one is not very interesting usually. Well, it is, but if it has weird data. What do I want to show you? The highlights, that's right. So, and this is just another copy of that. I can show you a different one. This one showing the time spent rendering one of these two halves of the screen. Then here I have this is per frame data. So this is the frame that you see, and then this is the number of visible clusters used or in this frame, and the number of light indices, total number of light indices. So these can contain duplicate light indices. It's just the total length of the whole buffer of light indices. I also have a histogram here. This is showing the fragments per cluster. Note that the x is logarithmic, so this fourth bin contains clusters that have up to 2 to the power of 4 fragments in them. I think something like that. Haven't figured it out exactly how to interpret this, but whatever. But a more interesting one maybe is the light indices per cluster. And this one is not logarithmic. This is just like the actual number of light indices used per cluster in a histogram. I'm sorry. So let's go over this simulation that I've done. This has 10 runs, of which the first one is just like outputting the frame and then this data, and then the remaining 9 are time sensitive profiling things, so those are shown here. I can just go over them, and I'm increasing the light count from 0 to 10,000, and then you can see that there's a gap here, which I think is probably caused by the drop in number of visible clusters. So there's 180 here, goes down to 100, just because of how we are looking at the scene, and this is using the pre-projective clustering, or like world space uniform clustering. And then it jumps up again, and the visible clusters jumps up. So that's pretty strong correlation. I think that's what's happening with these peaks. But then what's also interesting is to look at how long it's taking to render. It doesn't seem like much is changing here, but it goes up, and then there's a peak here, and it goes down again, even though the total number of light indices is not really dropping, right? But then what is changing is if you look at the histogram, at the peak, there's a lot of clusters with many lights in them. As we go to the right, like it shifts down into the lower end, and there's just many less lights per cluster on average, which is making it render faster, because for every pixel there's just less lights to iterate over. So that's cool. Yeah, and so what I want to add is this is just one data set. So I want to run the same simulation with a different configuration, so different rendering strategy, and then be able to put those two side by side, which is going to be interesting, hopefully. And so far, this is what I have. Pretty cool.